We are going to go to our next presentation, Development of Accelerated Bridge Construction Handbook. Dr. Islam Mantawi is going to present this on behalf of Dr. AZIZINAMINI. Dr. Mantawi, by the way, Dr. Mantawi, we still call Dr. Mantawi of our own FIU, but he's teaching in Rowan University. Dr. Mantawi?
Thank you, Dr. Marabi, and everyone listening to the presentation today. I'm gonna, on behalf of Dr. AZIZINAMINI, go through the different chapters and outline of each chapter related to the development of Accelerated Bridge Construction Handbook. This handbook will be edited by Dr. AZIZINAMINI and will have different chapters. And every chapter will be led by multiple authors with different citation option and referencing options, so you can get cited in each chapter. The version of this handbook is scheduled for December 2023. And as we go through the slide, I know there is so many information, but I will try to be as light as possible. There is some chapter were identified originally, and for the first version, which should be expected in December 2023, there's going to be a specific chapter, and after that we'll have version 2, which will include additional chapters. If you go to the next slide, the slides in red format, red font, you will have them in version 2, in white format version 1. So we have chapter 1, which is history of ABC. This will be led by Dr. AZIZINAMINI. Chapter 2, definition, also Dr. AZIZINAMINI. We just heard from Dr. Ibrahimian about decision-making tool. This is going to be chapter 3, summarizing the different existing tools within state agency and DOTs related to a choice of ABC. This will be led by Dr. Ali Ibrahimian and myself. Chapter 4 and 5, this is going to be for version 2 or revision 2 of the handbook, which are related to ABC construction technique and equipment for different equipment like lateral slide and SPMTs. Also going to be overall of AASHTO ABC guide specification. This is going to be in version 2. Chapter 6 is UHPC based solution by Dr. AZIZINAMINI to lead it. UHPC durability, Dr. Lau. Chapter 8 is ABC steel superstructure. This will be led by Dr. AZIZINAMINI. Chapter 9 is ABC concrete superstructure, Dr. David Garber from FIU. Chapter 10 is ABC substructure, Dr. Marabi from FIU. Chapter 11 is connections. This is expected for version 2 or revision 2 of the handbook. Chapter 12 is ABC seismic consideration, Dr. Bijan Khalegi. Chapter 13 is additive manufacturing of 3D printing with Dr. AZIZINAMINI. Myself will do chapter 4 for accelerated repair and upgrade. Available resources, chapter 15 for the next edition, second edition. Chapter 16 will be the design example for out of different chapter. This will be all contribution from different faculty from FIU and other participating faculty. And chapter 17 is international trend, which will be also in edition number 2. There's going to be a chapter in introduction of artificial intelligence and machine learning and helping extending the benefit of ABC. This will be determined later who is going to be the leader or the leading person for the chapter. So I'm just going to choose a few chapters to show you today the difference, the outlines of each chapter. There is a different level of completion in each chapter. So the chapter number 7 will be UHPC durability. This will be led by Dr. Kinsey Lau. We hear from him today. So the chapter will include introduction, application of UHPC material from bulk concrete, overlay, joint and repair, material consideration from mixed design, from cement factor, particle packing, and supplementary cementitious materials, fibers, and also application of UHPC in additive construction. Durability testing and durability behavior of UHPC from colloid penetration, carbonation, freeze and thaw, electrical characteristics, corrosion parameters, and surface wear and erosion or oppression. Material testing, the standard material testing for UHPC, and novel testing methods. So it's really focused on the durability aspect of UHPC. Some case study in section 5 of this chapter in terms of exited bridge construction, ABC, and other structural components, and actually challenges and prognosis of future use of UHPC. Chapter 9, Dr. David Garber from FIU is leading researcher or leading author in this chapter. And this chapter will have introduction and general introductory primary option for fully. This is mainly for concrete superstructure. Fully precast concrete superstructure includes section 3 different typical options for ABC. The first one is precast girder with full depth concrete the deck panels, as you can see on the screen here. Other option of deck pulp T girders, and another option with adjacent precast beams. Continuing, I don't want to keep reading the slide, but you will have a chapter in general precast design, how to calculate the pre-stress losses, how to calculate the section properties for composite, non-composite, and transformance section. General design procedure with steps from step 1, as you can see here, from choosing the cross section up to end of design the end anchorage zone and reinforcement. Also for full depth deck panels, the section of the work that Dr. Garber conducted a few years back, and also the partial deck precast deck panels. Chapter 10, I think Dr. Murabi is a leading author for this one. I believe Dr. Murabi, this is almost complete draft for this is ready, and hopefully will be included in the entire handbook as a chapter that Dr. Murabi is leading. Chapter 12 is led by Dr. Bijan Khaligi. He is leading the chapter related to ABC seismic consideration with different introduction for objective, responsive characteristic of bridge system and components, potential causes of earthquake damage in bridges, seismic hazard and performance. So the introduction is mainly overview of effect of seismic activity on bridges. And the bridge seismic design requirement is the second outline, which is seismic design criteria for AASHTO specification overview or review. What's the difference between force-based and displacement-based analysis and design? Primary design consideration and how to configure span to balance stiffness, computer modeling for ABC systems, and seismic resilience system with energy dissipating systems. Structural considerations such as foundation and all seismic protective systems, substructure element, abutment and integral and semi-integral abutment, pier and wall piers, bent cap and open frame bend, and also before soil integrated bridge system, which is another option for seismic resistance frame, system for bridges. Details of current practice from abutment connection to pile cap connection, superstructure continuity over piers, precast column to cap connection, segmental columns, and prefabricated concrete bridge systems. Also, application of a seismic research on ABC bridge element and system, superstructure and continuity types, superstructure with emulative or hybrid connection, some system for superstructure, substructure for self-centering capability using pre-stressed strands or tendons in either post-tension or pre-tension, substructure with alternative energy dissipation mechanism. The chapter 14 is accelerated repair and upgrade. I'm leading this one. Basically, we'll have introduction. You will expect to see different section within this chapter. The second section is accelerated repair of bridge superstructure, to focus on superstructure. You will have subsections related to what type of damage you have in the superstructure, material for accelerated repair of superstructure, method of repair for superstructure, and also summary of the key accelerated repair techniques for superstructure. Also, you'll have for superstructure feature project that features actually project with accelerated repair for superstructures. Same concept will be applied for section 3, this chapter, but will be applied for substructure. So you will identify different damage in as a substructure, what kind of material commonly used for accelerated repair of substructure, and what methods are used, what summary for the most common techniques and feature projects. Also for section 4, it will be focused on foundation. I don't want to repeat myself again, but all the different material methods and feature projects for repairing bridge foundation if damage is allocated to foundation. And at the end, design, decision and conclusion, discussion and conclusions and references. If you want to expand a little bit for superstructure, you can see different type of damages, spalling, corrosion, fatigue, different material be used, fiber reinforced composite, steel, UHPC, and shotcrete materials, different accelerated repair technique from application of flowable UHPC to shotcrete of materials to patchy sealing and externally bonded techniques. Same can be applied to substructure, and substructure, the damage also include the seismic damage, so you can expect structural damage due to seismic in columns, and you can also expect soil liquefaction. Chapter 16 is a chapter that's related to design examples, which very much the example throughout the handbook, and this will be by most of the leader of the different chapters that I mentioned. Chapter 16 will have design example following slide. So the following slide, actually, I'm showing one of the example for folded steel plate girder. You will expect in the chapter introduction an option alternative for the design for closure joint, either longitudinal or transverse, precast option, either full depth or partial depth. What is a turn down for construction, extended surface life, span length, barrier connection, and also fabrication and field erections. And this is a lesson learned. You will have a detailed design calculation from the bridge geometry to modular unit to steel sections to calculating the elastic section, the full depth, full bridge section, plastic moment, and cross-section properties. You will expect to see the full design for structural analysis using multiple present factor, live load distribution factor, and analysis for dead load DC1, DC2, and DW or live loads. Summary of analysis similar to the table that is given in FHW example, so it can have similar familiarities for the profession. The limit state from strength, limit state to surface to elastic deformation and permanent deformation. Also, there's going to be a section on fatigue and fractures for folded plate girders, from critical detail to fatigue 1, infinite to fatigue 2, finite life and fracture, and also dig design, which are related to constructability during lifting, from stresses to stability to lifting location to overturning stability, especially if you have the unit that has barrier at the end, and also the construction sequence. So in addition to that, the handbook also will have sections where you can scan code and you go to a web-based tool, QR code to go to a web-based tool that is being developed right now at FIU to help the designers and professionals to quickly design, use it for designing new bridges. And I don't want to. I think I have 2 or 3 minutes, and I think this is concluding the presentation and outline of different chapters. If you have any questions, please contact Dr. AZIZINAMINI at the email showing on this slide, and I'm happy to receive any questions, if any.
Thank you very much, Dr. Mantawi. Yeah, I'm part of this development of this manual, but it is really extensive and inclusive of almost all information available. We have a few questions. Let's see if we can address those. Yeah, we have time. So there was an indication on your presentation that version 1 would be available about end of this year, but there's a question asking what about version 2? When should we expect that one?
I would say I don't have definitive number or expectation when gonna be. I will say maybe a year after, but I think it depends on so many factors. Some of the chapters actually related to some developments that is going on in the research community. So I would say within a year, but if you need to confirm, maybe email Dr. AZIZINAMINI.
Sure. And again, just as this is something came to my mind as because you are also involved in this. Are we looking at this manual as a living manual, like because I saw that a couple of chapters as per new technologies becoming available, like that chapter 18, which is kind of blurry, meaning that so this will be added as we go. I mean, to the manual. Is that your understanding?
Yeah. Yes, I expect different editions and frequent editions for this chapter, but I think the vision now is to have the first edition by December 2023, the second one as soon as possible after, and as research expand and new technology comes to place, I think I expect more edition to come by adding or revising existing chapters.
Sure. One more question. We have 1 more minute to answer to take care of this. The question is, I'm kind of interpreting the question and adding to it. The question is asking that, will each chapter include a reference listing other than available resources on that topic? I'm guessing because all of us know that there are a lot of work done on this topic. There are several manuals and guides available outside. So how would we address? How would we reference those works or complement them? Or
my understanding is the priority will be given to directing the reader to the existing documents rather than referencing heavily in the handbook. So, for example, the chapter 5, right, which is ASHTO ABC guide specification, it will be brief because the guide is still is out there, but it can help the reader to navigate it. So, but it will not be like
repeating
other people, or it will be guiding people to other documents too.
Thank you very much. Thank you, Dr. Mantawi, for the nice presentation.
Thank you.